So we're going to walk through this next part. It's just the layers of our skin. So we're going to walk through the 3 layers of skin. Now, I will tell you that your skin is different in different areas of your body. So there are some areas of your body where your skin is really thick. It's like 4 millimeters thick. And then there are other areas of your body where your skin is really thin, maybe only 1 millimeter, 1.5 millimeter thick. Can you think of somewhere in your body where your skin is super thick? It's going to be somewhere where you need a lot of protection.
On your feet?
Yeah, so the soles of your feet and then palms of your hand, right? I remember as a kid, my brother used to like stick needle, like pins through his palms. I don't know, he was weird. He still is weird. But yeah, palms and soles of the feet, right? You have really thick skin in those areas because you think about how much friction these areas are generating all the time with what you're touching and walking on substances. Thin skin, can you think of somewhere where your skin is really thin? Like if it gets dry or cracked, it might bleed. Your lips, right? So lips have very thin skin. Your eyelids also have very thin skin, okay? So depending on where you are in your body, your skin's gonna range in thickness and it's gonna look a lot different. Now there's 3 regions to your skin, whether it's thin skin or thick skin. It always has these 3 regions, right? We have our epidermis. Now remember I told you when we started, epi means above or on top, right? So this is on the very surface is what you can see. And remember, this is made of epithelial tissue. So that's easy to remember, epidermis, epithelial. Remember, epithelial tissue has no blood supply. So remember, A means not. Vascular, so there's no blood supply. So this is how you can get a paper cut, and it can hurt a lot, but it's not going to bleed, right? Just under that, we have our dermis. The dermis makes up the bulk of your skin. This is a really thick layer in your skin. It is made of connective tissue, so it's very tough, and it's vascular. It has a fabulous blood supply. It has to have a blood supply. And the reason it has to have a blood supply is because the epidermis doesn't. Now remember, cells are living things. They have to get nutrients. So how your epidermis gets nutrients is through diffusion. So nutrients actually diffuse up from the dermis into the epidermis. And then under the dermis is the hypodermis. Remember, hypo means below. And the hypodermis is under the dermis. It is made of, I'll write it over here, it's made of adipose tissue. So it is made of fat. Serves a lot of functions, same functions that fat does. So it insulates, it cushions, it protects. Now, a lot of times we'll call the hypodermis, we have different names for it. One term is called the superficial fascia. So the reason we call it that is because if you think about your skin, right? If you were to go take your skin off, right under your skin would be your muscle, okay? And what sits on top of your muscle is this connective tissue. It's really thin, called fascia. You've probably seen it if you have ever cooked chicken breasts. If you've ever gotten a raw chicken breast, you know that sometimes you can pull that clear film off the surface of it. That's fascia. It sits on top of muscles. And so the reason we call the hypodermis the superficial fascia is because it sits on top of the fascia of your muscle. Okay, so that's another term for it. And then one other term that we can give the hypodermis, there's actually 3 names. We can also call it the subcutaneous fat. Sub means under, cutaneous means skin. Now, a lot of times, textbooks do not consider the hypodermis as part of the skin. The skin is the epidermis and the dermis. And then they say that the hypodermis is just subcutaneous fat. It's just a layer of fat under the skin. Now, your book sort of classifies all three layers in the skin, okay, in the integument system. So this is a great picture of your, very similar to this. So you can see in brown at the very top, that's our epidermis. Okay, that's made of epithelial tissue. It's lots of cells in there, so you can see all those little tiny cells. Then you can see this big layer in the middle, right in here, and that's all that pink layer. That's our dermis. And the dermis is the thickest layer, but you're going to notice here that it has a lot of structures in it. You can see all the blood vessels, you can see hair follicles, you can see glands in there. And then at the very bottom is our hypodermis, and you can see that as fat tissue. Anytime in your textbook that you see yellow, a lot of times that yellow is indicative of fat. Okay, same thing with models. A lot of times on the models that we'll use and images that I use in your lab, if it's yellow, it's probably fat. So this is an image of your skin, a microscopic image of the skin, which you're also going to look at in lab this week. And you can see the same three layers. So you can see at the very top, it's usually very dark, is our epidermis. Okay, this thicker layer right in here, that's our dermis. And then at the very bottom, and again, if you look right in here, that looks just like our fat tissue. That's our hypodermis. So we're going to go through all three layers, and I'm going to talk about the kinds of cells and the kinds of tissues that you're going to find in those three layers, okay? So we're going to start in the epidermis, and I'm going to walk you through the cell types in the epidermis, and I'm also going to talk about the layers of the epidermis, okay? So remember, again, the kind of tissue in epidermis is epithelium. Now, specifically, what kind of epithelium? Remember, we have two kinds, simple and stratified. The function of a simple epithelium is absorption, secretion, filtration. Function of a stratified epithelium is protection. So what's in your skin? The one that's protective, right? Stratified epithelium, it's a stratified squamous epithelium. More than that, it's keratinized. Keratin is that waterproof protein. Sorry, I don't know why it's connecting all those lines together. And so we're going to talk about keratin a little bit later, okay? Now the types of cells. One kind of cell, keratinocyte. Another is melanocyte. Merkel cells, which I mentioned, and Langerhans cells, which I've already mentioned. We're going to go through each of those. I'll show you where they're found in the epidermis. And then the layers of the epidermis. It says right here, 4 or 5 layers. That depends on whether you have thin skin, which would have 4 layers, or thick skin, which would have 5 layers, okay? So our layers are listed there. I'm going to go over those with you as well. So we're going to start with our cell types, right? We have 4 kinds of cells. The first one, keratinocytes. These actually are the majority of your epidermis. I'm going to start this because you're going to see a question about that on your exam this week. Okay, what is the main type of cell found in the epidermis? It's keratinocytes. And if we think about the name, right, we know cyte means cell. These are cells that make keratin, right? And keratin is that hard, protective, waterproof protein. All of these keratinocytes, they come from, I know we haven't done the layers of your epidermis yet, but they actually come from the very bottom layer of the epidermis. And this layer is called the stratum basale. We'll talk more about this one in a little bit. Stratum just means layer. And I always remember, I pronounce it basale, so I can remember to put the E at the end when I'm spelling it. Okay, some people call it stratum basal. I say stratum basale, bottom layer. And this is a layer in your epidermis where the cells are constantly going through mitosis. So they're creating new cells, and those new cells get pushed up. And that's why at the very surface of your skin, your cells are sloughing off. They're dead by the time they get up here. So your skin has a really high regeneration capacity because of the stratum basale, okay? Because it's constantly going through mitosis and it's pumping out and making a ton of keratinocytes. The dead keratinocytes, by the time they get to this top layer, they're sloughing off, right? And you notice it more when your skin is dry. Like if your skin's really dry, some people call it ashy, right? You might notice it. I remember as a kid, like I would write my name in my leg, in my dry skin on my leg. That's gross. I shouldn't tell you all that. You might see extra keratin being formed in places where you have constant friction. So places like your feet, the soles of your feet, right? Calluses, palms, calluses. If you have a really hard callus, the reason it's there is you've produced extra keratin in that spot. So that's why your skin feels harder right there. When I went to undergrad at Ohio State University. And when I was at Ohio State, I was on the crew team. I was a rower. And I remember how awful my hands were when I was a rower. I would have huge blisters and huge calluses all over my hands because of the constant friction from the ore. So this is a picture from your book that is showing you only the epidermis. Okay, so I'm going to click back here. So again, all we're looking at right now is this part right up here. Okay, so notice how, I'm going to erase what I just did. Notice how this very top epidermis, it kind of does this, and it has all these invaginations. We're going to talk about why that's important in a little bit. But if you go here to this picture, you can see we are zoomed in so much. You see that one of those invaginations just right there. Okay, all the rest of this in purple, that is all the epidermis. Now, that image on the left, that is a microscope slide. The image over here on the right, this is an artist rendering of that, and that's the image I'm going to use as I talk about the different cell types because it's easier to see them. So do y'all see on the right, all of those orange colored cells? Those are all keratinocytes. So you can see they make up the majority of the epidermis, right? It's mostly keratinocytes. Another kind of cell that we'll find in the epidermis is our melanocytes. Now again, cyte means cell. So melanocytes make melanin, right? Keratinocytes make keratin, melanocytes make melanin. Now I mentioned melanin already. Melanin is that protective pigment that gets released and helps to protect your cells from UV rays. So melanin is made by melanocytes, and a melanocyte is this gray one down here at the bottom. So notice we don't have a ton of them, but we do have some. That melanocyte will make melanin. It stores the melanin in little vesicles called melanosomes. Those melanosomes then get pushed out of the melanocyte and they get taken up by keratinocytes, right? So all these orange cells, if you look at them, you see how they have these little gray circles, these little tiny vesicles in them. Those are melanocytes. Those are melanosomes. So the melanocytes makes the melanin, puts it in a vesicle, and then lets keratinocytes take up the melanin. And so now these keratinocytes, which are making up the majority of your epidermis, are protected from UV rays. So remember, this is the pigment that when UV rays hit your skin cells, those little vesicles of melanin move to the sunny side of the nucleus and shade it out, create a little sunshade. Another kind of cell that we find in our skin are called Langerhans cells, and they are these purple guys over here. Langerhans cells are part of your immune system. These actually come from your bone marrow. They are white blood cells, and their job is to recognize a foreign antigen. If they see something foreign, they gobble it up. they also activate the immune system. So remember, I mentioned to you earlier that these are part of the first line of defense. So if a Langerhans cell sees a foreign organism coming into your skin and recognizes it as foreign, not only will it gobble it up, but it'll activate your immune system and tell your immune system, hey, there's an invader in here and you need to watch out and monitor the bloodstream and make sure that it doesn't get any further. Now, one thing that makes Langerhans cells so great in your skin is that they have these really long branchy processes that kind of snake in between all these keratinocytes. So that if you have something sort of moving in between your keratinocytes, a Langerhans cell will pick it up and gobble it up. They'll recognize it as foreign. And then the last kind of cell is called a Merkel cell. And that is this guy right here. Merkel cells are, they're going to pick up light touch, but notice that it is connecting to this yellow structure right here. That yellow structure is a nerve ending. So Merkel cells are always associated with nerve endings, and they're keeping the nerve nice and healthy. So they're picking up light touch, but they're also helping to make sure that nerve stays nice and healthy. All right. So those are the different kinds of cells in our epidermis. We also have the layers of the epidermis that I want to walk you through, okay? So the very bottom layer, I've mentioned this one, is this one cell layer thick right here. That's our bottom layer of the epidermis. That's called the stratum basale. It's the deepest layer. It is connecting to the dermis, right? This pink part poking out, that's the dermis down there. And it's basically just one cell layer thick. It has keratinocytes in it. It has melanocytes in it. It has Merkel cells in it. Now, I mentioned to you that this is the layer that is constantly going through mitosis. So sometimes you might find in your textbook, they'll call it the stratum germinativum, which literally translates into the germinating layer. So it's the layer that's constantly going through mitosis, rapid cell division. Now the next layer up, I'll circle that one, is this layer right in here. And this is called the stratum spinosum. So this one is a little bit thicker, okay? It's several cell layers thick. And I always remember spinosum and I think spiny. Sometimes we call this the prickly layer. Because what happens is when keratinocytes are made in this very bottom layer, the stratum basale, when they're brand new, they're like babies, right? Babies are big and plump and juicy and they got the big cheeks and the big legs. Same thing with cells. When cells are brand new, they're big and plump and juicy. And as those new cells move up towards the surface, just like babies, as they start growing and getting longer, they thin out. Same thing happens with your cells. The cells start to actually thin down and get smaller. But all of the cells that are in your skin in the epidermis are connected to each other. So what happens is they start out big and plump, right? And as, I didn't really put that in the right spot, did I? They start out big and plump. And as they move towards the surface and they get smaller, they're still connected to each other. And so because they're still connected to each other, they end up looking a little more spiny at those connection points. Okay, so that's why we call this sometimes the prickly layer. We do find all those keratinocytes that are in the stratum spinosum. Remember, they've all taken up the melanosomes. They've taken up those vesicles, so they're nice and protected from UV rays. You also have Langerhans cells in this layer. The next layer is the stratum granulosum. Now you're going to notice in that layer right there, the cells, the keratinocytes, look different. A lot of times the keratinocytes are very flat, but they also look very grainy, and you should be able to see that. You can see all those little granules in there. The reason is that this layer, the stratum granulosum, is making keratohyalin and lamellated granules. These provide the waterproof coating in your skin. So Remember, your epidermis does not have a blood supply. Notice that nowhere in here can you see a blood vessel, right? So remember, how's it getting nutrients to all these cells? Through diffusion, right? Nutrients are diffusing up from the dermis. And those nutrients can diffuse up until they hit this waterproof layer right here. Then they can't diffuse up anymore. So what happens is, even though you need this waterproof layer in your skin, it's really important to have it so that things can't get into your skin. It's actually preventing nutrients from getting up to the rest of your cells. So effectively, the stratum granulosum, by making this waterproof layer, it's kind of strangling itself. So these cells are starting to die. That's why they look grainy. As a cell dies and the organelles die, you get this grainy appearance. So that's why I remember stratum granulosum, grainy, looks very grainy in appearance. All the cells above the stratum granulosum, they're all dead. And you know they're dead because notice if you look up in here, you see no nuclei. Those cells have already the nuclei and all the organelles have disintegrated because they're not getting nutrients anymore. Now the stratum lucidum, this is only present in thick skin. Now, we don't see it in this artist rendering. Where we would find it would be right in here. Okay, this would be the stratum lucidum. It sits right on top of the granulosum. And I'll show you an image of it so you can see it. You'll see it in your lab manual as well. This one gives you sort of this transparent band. And I want you to think about, if you look at your palms or if you look at the soles of your feet, a lot of times if you look at where you have a callus, notice how it looks kind of translucent in color. That's because you can see that stratum lucidum in there. Okay, so this is a great image where you can see this lucidum. On the left, we're looking at thin skin, okay, that does not have a stratum lucidum. On the right, we have thick skin that does have a stratum lucidum. Okay, so I'm going to use the one on the right. So we've got this first layer down at the very bottom, one cell layer thick, right? That's our stratum basale. All of this in here, that's all the stratum spinosum, where it looks spiny because the cells are shrinking down. That dark band is always the stratum granulosum. And now you can see right above that, you see that sort of pretty translucent band. That's the lucidum. Again, you're only going to find that in thick skin. If we look at the left, again, we still see the same layers, right? Stratum basale. All of this is the stratum spinosum. Again, you've got this dark band is the granulosum. Okay, the dark band is always the granulosum. All right, and then the last layer, the last one at the very, very top that I have not talked about yet, you can see on both of these is the stratum corneum. This is a very thick layer of your epidermis. I remember this one because I think corneum, cornflakes. And if you look at the image on the left of thin skin, it looks like cornflakes stacked up. This is the flaky layer. This is the layer that's going to flake off, right? This is all dead. And so this is the outermost layer of keratinized cells. So all of this is the stratum corneum. It makes up about 3/4 of the thickness of your epidermis. And it has a lot of functions. Because it's all dead, it's great at protection. It's got waterproof protein in there, so it is a waterproof coating. Protects from abrasion, wear and tear, chemical, biological assaults. So having this stratum corneum is so important. And the thicker it is, the more protective your skin is. All right, so that is our epidermis. So everything that we just talked about is just this tiny little layer at the very, very top. Okay, so all those cells, all those layers. So your epidermis has 4 or 5 layers depending on how thick your skin is. The next layer down, the dermis, is the thickest layer of your skin. Derma means skin. And this one's very different. Remember, epidermis has epithelial tissue. The dermis, this middle layer of your skin, is not epithelial tissue. It can't be. Epithelium does not have a blood supply. This is made of connective tissue. right? So the type of cells that we find in the dermis are fibroblasts. So that should tell you a lot. Remember, of all of our connective tissues proper, cartilage, bone, and blood, fibroblasts are connective tissue proper, right? So we know, all right, in your dermis, this is a connective tissue proper. We have loose and dense. The other kind of cells that we find in the dermis are macrophages, mast cells, and white blood cells. So right there, that tells you the function of your dermis. It is there for immunity. It is there for protection. That's important because your skin's an organ and it covers the entire outside of your body. It is your first line of defense. So you want cells that are in there to help fight infections from getting deeper into your body. Now, your dermis is innervative. It does have nerves, and it also has to have a blood supply because remember, the epidermis doesn't. So nutrients are going to diffuse up into that epidermis from the dermis. Now, unlike the epidermis, which had 4 or 5 layers, the dermis only has 2. So that makes it a little bit easier. Okay, so we're going to go through those 2 layers, and we're also going to talk about the tissues in the dermis. So this is an image on the left of your skin, right? Everything in pink, that's all the dermis. Now your dermis has 2 layers, and those 2 layers have different tissues in them. So the layer at the very top up here, that layer is called the papillary layer. The layer deeper is called the reticular layer. Now the images on the right of the papillary and the reticular layer are scanning electron micrograph images. And you can see that the tissues in those layers are very different, okay? In the papillary layer, we have a loose connective tissue proper called areolar tissue. Has a lot of white blood cells in it. It's very loose, it's very spread out, so white blood cells can patrol the area. That should make sense that you have that way up here at the very top of the dermis, so that if an infection were to make it through the epidermis, now you've got some white blood cells and macrophages in that areolar tissue patrolling the area, keeping it safe. Deeper down in the dermis, you have a different tissue. Deeper down in this reticular layer, you have a dense connective tissue called dense irregular. Now, when you look at that, dense irregular, to me, it looks like if you've ever taken yarn off of if you've ever taken yarn and made a little yarn ball, that looks like a yarn ball to me. What you're looking at, remember, dense irregular has a lot of collagen fibers, which are stronger than steel, running in different directions. So it provides a lot of strength in different directions, right? So this is what you're going to find down in that reticular layer, something nice and strong, being able to withstand tension. So let's go through those 2 layers, right? We're going to start in the papillary layer. So that's this top layer up here. So that's where we're going to start. Again, this is made of areolar connective tissue. It's airy, it's spread out, it's a loose connective tissue. It has tons of blood vessels. That's important because it allows it to diffuse to the epidermis. And because it's loose, it has a lot of white blood cells in it, macrophages, mast cells that can patrol the area for bacterial infections. Now, another thing that I mentioned that I would talk about in a little bit is if you notice, when you look at this papillary layer, notice how like the bottom of the epidermis and the top of the dermis have all these little like ridges. You know, it's not like a nice clean border. It's sort of all these ridges and invaginations. And so those projections are called papillae. So this is why we call it the papillary layer, because it's where all these papillae, these invaginations are. And within all these little papillae, within these little grooves, we're going to find a lot of capillaries. So capillary loops, bringing that blood to the area, allowing it to diffuse to the epidermis. We're going to find Meissner's corpuscles, which help with touch receptors. We're also going to find a lot of free nerve endings. So this is important so that you're picking up sensation from your skin. Now, all these little papillae, these dermal papillae, these are also going to help in other ways. I'm going to go back to this picture. I want you to imagine that the papillary layer of your dermis and the epidermis, instead of having papillae, let's say it's nice and flat and they come together like this. If you were to put friction on your skin, those two layers would separate. But instead, the epidermis and the dermis at that papillary layer, they come together like this. So when you put friction on your skin, they actually hold together a lot better. And so you're going to have deeper papillae anywhere where you have more friction. So palms, soles of the feet. So these are responsible for providing you with friction ridges, your fingerprints, right? You find these friction ridges where you have a lot of friction, and they help to enhance your gripping ability, right? These are patterns that are genetically determined. We all have different fingerprints, okay? Just under the papillary layer is that much thicker reticular layer. So I'll go back to this picture. This layer in here, right, that's our reticular layer. That's made of that dense, irregular connective tissue. It makes up about 80% of the thickness of your dermis. I don't know why it does that. There we go. And remember, dense irregular has collagen fibers that are arranged in a hodgepodge so that you can withstand a lot of tension from different directions. So it gives the skin a lot of strength and a lot of resiliency. It protects from scrapes and penetrating wounds. It also helps to bind water, so it helps to make your skin moist. I notice that the older that I get, if I am dehydrated, I'll get much bigger sort of sags under my eyes, those bags that you get. And the more hydrated I am, those plump up a little bit more, so they're not quite as noticeable. So staying hydrated is really important for your skin and for the rest of your body. Now you also have elastic fibers in this dense irregular connective tissue, which allows your skin to stretch a little bit. Now this is an image, I stole this one from Google because your textbook does not have an image that looks this good. So I love this picture. This is thin skin, right? You can tell because if you look here, right, we've got our stratum basale, right? This is all, everything above this line, that is all the epidermis, right? Stratum spinosum. You see that dark band in here? That is the stratum granulosum. And notice there's no lucidum in here. You go straight to the stratum corneum at the top. So this is thin skin. But I like this image most because of the dermis. If you look at the dermis, so everything below that little red line that I drew, notice right in here, so I'll draw a line, that everything all in here, this is all the papillary layer. And you can look at that layer and tell that that tissue in there is different from the tissue down here in the reticular layer. So again, remember, this is areolar. It's a loose connective tissue. It is great for having white blood cells being able to move around and patrol. Everything down in the reticular layer is dense, irregular connective tissue. Okay, you can see all those collagen fibers in a hodgepodge. Now, a couple things that I want to mention about our dermis are just a couple of imbalances. So one that I mentioned a little bit in chapter 4 is that that dense, irregular connective tissue is really strong and it's great at withstanding tension, but it is not foolproof. If you put too much tension on your skin too quickly, then it will tear. And you'll see it on the surface as those white silvery marks, which we call striae. You probably call them stretch marks, right? So pregnancy growth spurts, weight gain, all of these things, if they happen fast, it can lead to stretch marks. Now, another imbalance I want to mention are blisters. So remember how when we look at this papillary layer and the epidermis, how they come together like this, right? Because you have these papilla, these invaginations. And I told you that that's really important that we have that, because if your skin came together like this, right? If it were flat without those invaginations, if you put any tension on it, it's going to separate, right? Anytime you put too much friction on your epidermis and it causes it to move away from the dermis, you get a fluid-filled pocket in there called a blister. So that truly requires a lot of friction. So, you know, if you're not used to, I don't know, doing a lot of work like shoveling or raking, you know, and in the fall, all these leaves fall and you've got to rake up all the leaves and you spend all day doing it, you might end up with blisters on your hands because it's not something you're used to. You haven't built up calluses, right? You've put so much stress that you've separated your epidermis and dermis, okay? And you get that fluid in there. So that's what causes blisters. Now, the last layer of our skin that I'll walk you through is the hypodermis. Again, some books don't even consider this as part of your skin. They say it is subcutaneous, that it's under your skin. So that this is basically just, your skin is just the epidermis and the dermis. And this layer of fat down here is not really part of your skin. So your book classifies this layer as the hypodermis. So it is found beneath the dermis. And it's mostly adipose tissue, right? It's mostly fat. So it has all the same functions of fat. It is protective, it insulates, it absorbs shock, all of those things. This layer of fat in your hypodermis is very typical that this layer will increase when you gain weight. So typically when you gain weight, if you eat more calories than you burn throughout the day, your body's going to store it as fat. And typically you're going to store it as subcutaneous fat. Your book says that it depends on males and females as to where you put that fat. It says in females, typically thighs and breasts. In males, they kind of get that spare tire in the abdomen going on.